So good morning, everybody, and welcome to ITIF. Fortunate to have three people here who were all very closely involved, worked very closely with the FCC on this recent study, and have very strong technical backgrounds in performance measurement. And so this panel is going to be a little bit different than the typical K-Street event, and that we're going to completely geek out today. Okay, there's no question is too complex. Nothing is too technical. It's not going to be a policy-oriented discussion. This is to actually understand the technology that's behind the policy that we may or may not want to impose on it. So our speakers, we have Alex Salter, who's the CEO of SamKnows, which is probably the best known and one of the most respected broadband measurement companies in the world. They currently have projects in 4 continents and 35 countries, involving consumers, ISPs, regulators, and academics. Alex may want to tell you the background of how SamKnows got started, but it was practically a dorm room project, as I understand it.
That's correct.
Peter Sevcik, the president of NetForecast, is a leading authority on measurement, assessment, and improving the performance of networked applications. He's contributed to the design of more than 100 networks, including the internet, and to the success of more than 25 application management products. And he's got a long bio. I'm not going to read it all. It's on the website. It's quite impressive, I'll tell you that. Steve Bauer is a research affiliate at the MIT Computer Science and AI Laboratory, which people who are familiar with academic computer science recognize as one of the leading, if not the leading, computer science research labs in the world. He got his PhD working in the Advanced Network Architecture group with David Clark, the former chief architect of the internet. And Steve's research focuses on issues that have both technical and policy implications. And he's very sort of deeply embedded in both the policy and the tech worlds. And he has very detailed knowledge of the SamKnows method and TCP and all of that. So without further ado, I think we'll just, the panelists are going to give brief presentations, then I'll ask some questions, and then we'll open it up to the floor. So, you going to start, Steve? Alex. Just press the button on the machine.
Yeah. The slide remote is.
Oh, that's what you're pointing at.
Let's see if this is set up.
My strong thermos thing.
What happens here, Richard, with the presentation? Will it appear?
Yeah, they'll show up here.
Who should be first?
Alex?
Just trying to work out how the mouse works. How does that work, Richard?
Scroll wheel or?
Sure. So as Richard said, I've prepared a few slides here just to help me just run through an introduction to SamKnows and the project with the FCC. So as of today, we're working with Ofcom in the UK, which is for us where it all started. The FCC, obviously in the States, we had a meeting on Wednesday with the FCC to kick off the second phase of that project, and then we're actually about to launch the European project on Tuesday, the same day as my wife's birthday, so it should be an interesting day. Our work in America with the FCC started with a strategy paper that we wrote in November 2009, and that was after they tried a couple of times to measure broadband performance. That document was turned into by the FCC a request for tender, which actually quoted a third party that worked with Ofcom. At that time, we were the only third party, so we were pleased to see that in the tender documents, obviously. But the one thing that we'd already run this project before in the UK, and we'd had success with it, but we'd also learnt a lot from that. And one of the big things that we learned is that the Ofcom project was done without any participation of outside parties. It was just us running a blind trial with Ofcom. And one thing that we were very keen to do with the US project is run it in a build on what we'd already learned, but run it in a slightly different way. One of the principal differences there is collaboration. We were very keen to get the ISPs involved, the academics, the researchers, and anyone that wanted to participate, consumer groups, and as a consequence, the FCC set up a collaborative working group which met right the way through the project and discussed almost every element of the project, which was fantastic for us because we could have an opportunity to talk to engineers at companies like Comcast, AT&T about how we can make our performance measurements work and what the methodology should work like from a technical perspective, right the way through to how we should be presenting this information to the general public. So one of the other changes that we had over the UK project is that in the UK we ran a very traditional market research panel. We found people and we incentivized them with monthly amounts of money. But we found that causes a problem because we skewed towards people who just signed up for panels rather than people who are interested in broadband. So in the US, we tried what we refer to as a multi-mode recruitment strategy. We used the media. It picked up a lot of coverage because this is a very hot topic. And from that, we built up a panel of initial volunteers, which we then applied our sample plan to and got that down to our final panel, which is what we based the FCC data on, and also what we still have out currently, which we're going to use for phase 2 as well. One of our concerns when we started that approach was how many volunteers we were going to get, but as it happens, we needn't have been too concerned because we've got over 250,000 volunteers just in our projects in the UK and the United States, and we just don't have enough devices to send out to these guys. As we move on to the next phase of the FCC project, they're looking to measure the same areas but in more depth, looking back in terms of measuring Wi-Fi in the home, for example, but they're also looking to change the scope slightly to look at rural broadband. That's something that we were discussing on Wednesday. So to touch on the measurement platform, when we started this, as Richard said, in effectively a dorm room project, what we wanted to create is a very portable code base that could be put into any gateway device or CPE. And what we've been doing is very much staying close to that initial thought, and we've spent the last 3 years developing this, making it very portable, making it very efficient in terms of the amount of space that it needs in terms of memory and processing power. And the other thing that we've done since working with the FCC is ensure that what we're building is very scalable. So this is something that we're running on 10,000 units, but it could very easily run on many more. So that's what we're looking to with the next phase of the FCC project. And obviously it's compatible with multiple vendors. We're working with Technicolor, Netgear, TP-Link, Cisco. And those are ones that we've previously used in our panels around the world. So just touching on one of the subjects that's the purpose of this talk. So before we spoke to the FCC, they just then published a report which showed that ISPs were performing at maybe 50% of their advertised speed. This was based on a software-based test where software was put onto PCs. Obviously, with our report, we confirmed that the ISPs were actually much closer to their advertised speed, and there's a number of reasons for that, which I can pick up on if we want to get onto that in the questions session. So just to talk to how the white box works, we have this code, we put it into home CPE, and the volunteers either replace their current router with it, or they plug it in behind their router, and it runs tests on the termination point of the internet back out into the network. We make sure that we don't run any tests whilst the volunteer or anyone in their home is using their internet connection. We also make sure we schedule the test so we get a nice 24/7 profile of the performance of the line. In terms of how that tests out, we test to popular websites, and those are ones that we agreed with the collaborative and the FCC. We also test to both on-net and off-net test nodes. So the ISPs donated something in the region of 100 servers, which we used to test performance throughout the ISP network. But we also had the off-net test nodes, which is and for that part of the project, we partner with an organization called MLabs, who supply a research platform that people can use. Once the tests are run, the white boxes then call home once every hour to either collect new tests or change the schedule, and they push the results up to our reporting servers. And then in terms of how we publish those, the volunteers have access to a web portal. We email them a monthly report card, and they now, I think in the next week, they have access to a smartphone app as well. So just a few features of what we think is important about this kind of measurement platform is that it automatically verifies the ISP, verifies the broadband package. That's absolutely key and fundamental to the study that we've just done. I see that as one of the big things that we spent a huge amount of time on, where people may have spent less time on previously. It's got to collect a 24/7 data profile, so you can see how the ISPs perform off as well as on peak. It's no good if your ISP is doing well at 4 o'clock in the morning when you want to use it at 9 o'clock in the evening, which is what most of us want to do. And then we just don't want to ask too much of the volunteers. We want it to be simply plug and play, and that's what we think we've achieved, certainly with the later versions. And then finally, the code base that we've developed and the whole framework is ready to be embedded into manufacturers' devices. And moving on to probably the most important part of the study, alongside collecting reliable data, accurate data, is making the data freely available. So this is a big part of the FCC's goal for this project, to create a data set that they could make publicly available for themselves, for ISPs, for academics, for researchers, and for consumers. Now, just picking up on the reporting there, we obviously report out to the consumer in a number of ways already. This is a big area for us in 2012 for the next phase of the FCC project. We thought this document was very good, the FCC's document, but we think that more could be done for the consumer in terms of making this information more accessible. So just going back to that point, obviously alongside the web-based dashboards and all the other tools we've got, we've produced these reports for Ofcom and for the FCC, and hopefully early in 2012 we'll see one for the European Commission alongside there as well. And as Richard said, as of our launch on next Tuesday, we'll be active in UK, US, and then the 27 member states of the European Union, plus 3. And then we have other work that we're doing in Central America and Asia, which is going to keep us busy. And just taking the areas where we're working at the moment, it constitutes about 46% of the global market for broadband consumers, active on 2 continents, and as Richard said, in early 2012, we're just looking to expand what we've got out. Our goal from the start has been to create this platform that people could just come and use, and create this data set that people could analyze and use for their different purposes, and really that's a big part of it. We've standardized on the architecture and the technology, and now it's a question of just making it available to as many people as possible. And just quickly, just to sum up, new areas for 2012, reporting, it's something that we're spending a huge amount of time on at the moment. How can we make this data most useful to the consumer? We're riding a wave of innovation in terms of customer CPE, and so it's just constantly getting less expensive and smaller, which I'm delighted about, because the first units we purchased cost us about $250. Now we're talking about $10 or something like that. So it's very exciting. And the new device that we're working on at the moment is mobile enabled as well. So it's going to give us a chance to go into new areas. We've got a methodology for measuring mobile broadband. There's a lot of transferable technology here, and so that's something that we're very excited about as well. And that's a 100-mile-an-hour run through of SamKnows, the methodology, and where we're at now and where we're going to be in 2012.
Yeah, so hopefully we're going to drill a little deeper into that after everybody does their opening remarks. So, Peter?
So what NetForecast does is analyze the data from this source and many other sources. We're in the performance measurement and analysis business. And what we've certainly been involved with the SamKnows measurement data now for better than 2 years. And here's a brief assessment of what we have learned from just this particular first wave of the data that came out in the FCC report. Okay, this is not. Oh. Stuck again. Let's do that button instead. Okay. So, as Alec explained, there are really 3 major parts of this. There's the measurement at the customer premises, which are referred to as the white boxes. Those measurements and how they operate, we think, are extremely accurate. It's the most accurate alternative available these days. Much better than the software-based systems that were attempted before, and because it not only is a predictable and repeatable test, but it also provides a lot of very precise instrumentation. Very exactly, it feeds, it produces data of fine granularity that can be analyzed all kinds of ways. So that is very beneficial. The other side of the test are the servers that it's talking to, and Alex explained that they came from various sources, and because they came from various sources and they were also under various administrations, they're not as well controlled. In fact, I think there was a lot of effort to really make sure that the white boxes were in the right kind of homes and were properly connected and the like. The server side had a variety of sources of where the servers came from, and they're under a variety of controls and administration. In fact, some of them were used for other things. So it wasn't quite as controlled as one would have liked, and I think that we should really improve upon that. And the third part is the data analysis. What does one do with all this data? And even though the FCC report is a fine summary, how the detailed data got moved from raw data to the report is sometimes mysterious. Which panelists were in, which ones were out, how was it all sifted and sorted? Yes, the data is made public, and one can analyze it their own way, but to actually reproduce the FCC method is a hard thing to do. And there was a lot of talk initially about how the data was going to be analyzed and presented, and then at the end, what was really in the report was slightly different than the way it was being promised. But I think we need more transparency in the FCC's analytic methodologies. So that's the assessment of where we are. But I thought our assessment as to where we are. I thought it would be useful to actually ask some other questions, which is that we've been really focused on. We keep hearing this word that we're going to really measure speed. And I would just like to point out that the ISPs don't deliver speed, okay? They deliver bandwidth. And in fact, the FCC Broadband Plan, which is a wonderful document, which is not the same as this report, a predecessor, is a great report that's got 360 pages, and it uses the word speed 360 times, but only uses bandwidth 40 times. Well, what is it that really matters here is bandwidth, and bandwidth should really be viewed as fuel for the internet, fuel for the internet experience. Okay, so I would like to continue sticking with the word bandwidth. I don't expect the industry to change. I expect everyone's hooked on speed, and they're just going to stay hooked on speed. Okay, but as an engineer, I thought it'd be valuable to simply say that it is bandwidth. So the real question is, we got in the report, are the ISPs delivering the bandwidth that they advertised? By service tier and by ISP. That's in the report. But a question that I thought worth asking is, if you have a lesser service, a lower bandwidth service, should you buy the more expensive, higher bandwidth service? What happens if you buy more? Well, here's an interesting analysis of the data. There we go. Now it's a different button. They keep changing which button works. Okay. So on the vertical axis is the percentage of delivered versus advertised as exactly the way the FCC calculates it. Okay. And it's using the same data set that is in the FCC report. But if you look at all of those data points in the FCC report, they're scattered all over the place. So what I did is I just grouped them by the trend. And I just created a graph of the 95th percent confidence interval to see where we are. Okay. And now there are points still above and below this because there are still samples that are above and below this. That is true. Okay. But the trend across 24 hours all week is in the green zone. The red line is the 100%. 100% is you're getting exactly what you expect. And you'll see that in the low side, if you're a customer who's down around 1 to 5 megabits per second service, you have a probability of not getting 100%. And if you're way at the high end, your probability of beating 100%. And if you're right in the middle, there's a big range right in the middle where you do get 100%. That's exactly what the conclusion of the FCC report was. But there is a clear slope to this line. Okay, and then if you look at the peak period, which is the 11 to 7 Monday through Friday, yes, performance drops a bit, but the same slope exists. Okay, so this is great because the conclusion is that, in fact, if you pay more to get more, you'll actually have a better chance of getting more. Okay, so go out there and buy some more bandwidth. But then I asked the question, well, why should you buy more bandwidth? Well, of course, video and all these other, video is a big consumer of bandwidth. So you might want to do it for video. But actually, you might need to do it just for the regular web experience. So let's talk about speed now, finally. Let's actually talk about speed. So what does it take to make speed happen? It takes 4 things, it turns out. And bandwidth is one of them, it's one of the boxes, okay? And the internet is really a supply-demand kind of system. And there are 2 things that are supplied, bandwidth and latency. And they are being chewed up by payload and turns. Turns is the number of round trips you have to do to get a web page to show up. Okay? Think of it as turns per click. Think of it as payload per click. Okay? And yes, if you buy more bandwidth from a very low level and buy some more, you will actually you'll see the response time get a little better. But it tops out because the turn count, the number of round trips, is actually going to start limiting you. And the FCC observed that in their report. They said at about 10 megabits per second, it doesn't go any faster. Now, we're in the speed business, but at 10 megabits per second, it doesn't go any faster, the website. And that's actually optimistic. We've actually seen it that doesn't go any faster even at 5 megabits per second. It all depends on where the server is now. Okay. So the crucial thing is that the driver are the 2 things below, payload and turns. What do they look like? Well, we have been profiling applications since 1995, since basically the web kind of burst onto the scene, okay? And we've been measuring the payload now for quite some time, since 1995, and we just measured it recently for the purposes of this meeting. And it's amazingly consistent. The compound annual growth rate of the payload is 20% a year since 95. And every time we checked it, it still continues to be 20% compound annual growth rate. So, I have to buy more bandwidth because I have more payload. That comes down with every web page. I get that. But there's a new payload that people don't know about, which is what we're calling, the clandestine traffic or the hidden traffic. There is a tremendous amount of traffic that's going on between your clicks of web pages. And that is growing at 10% a year. That's all of we got to exchange these cookies and we got to figure out which ad we're going to give you. And, I think that happens. These are all great features. In fact, just turning on Google's Chrome produces 6,000 bytes per second. Just sitting there. Okay? Well, that's a big contributor to the consumption side of things. Okay? The other thing you care about is the count, the turn count. Now, these are the round trips, and this has been consistently going at 12% a year. I keep predicting that this is going to hit a limit because, in fact, the speed of light is going to limit you, and if this thing keeps climbing, eventually it's just going to take forever to get a web page to come down. But nevertheless, it's compounding 12% a year since 1995. It's amazing. It's amazing. Now, I'm not predicting that the internet's going to melt down. I'm not predicting that this is going to be, that something's going to disastrous is going to happen. I'm just talking that in the great scheme of supply and demand, the demand side is doing some amazing stuff. Okay. So my conclusion is that if you take a look at those 4 boxes of what it really means to deliver the user experience, what the FCC did is a great job at dealing with the bandwidth and the latency. We didn't talk about latency here, but there's a lot of latency numbers here as well. They did a great job on measuring, reporting on, and we should continue to measure and report on the supply side, the energy, the fuel side. But who's asking and who's measuring the consumption side? Okay? Today, if you buy, you want to know that it's going to be 110 volts, 60 cycles, and watts are being measured correctly, and I'm buying watts in electricity for my home. But every appliance I buy comes with an Energy Star that tells me what the refrigerator is going to consume, what the TV is going to consume. Where's what the Facebook and Google are going to consume? Who's measuring that? That's the other half of the whole economic pie here. So I think we're only half done, and I'm looking for the organization or the body, anybody, public, private, regulatory, non-regulatory, government agency. I don't care who does it. Somebody should be asking the questions around those question marks.
Okay, Steve?
What was the magic number to hit?
Now it's this one, but
This one?
No, the middle one.
Got it.
If once you get your slide.
It's coming.
You want this?
Yeah, the thing is controlled by iPhone. Steve?
Well, I can tell you what my first slide is anyways. Overall, oops, can I go back? How do you go back?
How do you go back?
Oh, man.
Close your eyes.
Only the one thing
Said
that
not to go back. All right. So my first point was, it's a good process. The first policy relevant thing many years ago when I was much younger that I had done was work at a US Senator's hometown constituent office. And the lesson that I had learned there was not to care about outcome, care that there's a fair process in place. And I think that the FCC and SamKnows deserves a lot of credit for running a very good process. They took input both from my research group as well as the other research group that participated from Georgia Tech, as well as from all of the ISPs that participated. I was very pleased with that. It's a good report. I think the FCC deserves credit here. While it doesn't look at all of the data that SamKnows has collected, they do a good job at answering the main question that a lot of folks were asking, which is, are consumers getting somewhat close to the speeds that they're signed up for? And then good results. And here, I think that the credit goes to the broadband service providers themselves. We've spent collectively tens of billions of dollars, I think, building out broadband infrastructure in the United States, and it actually does perform fairly well. Why am I, as a researcher, pleased to be participating in this process? It's because we've really collected an interesting data set here. There's raw data available on the FCC site right now for 5 months of SamKnows data for 13 different tests. We've just begun digging into this. There's a lot of interesting things here. My research group at MIT has begun to dive into this data. Georgia Tech has already actually published 2 research papers that have made use of small slices of the data, but it's still interesting. There's the New America Foundation, which is here today, has begun diving into it. Google has been looking at this data. NIST has been looking at it, and I imagine that there's others that I don't know of as well. The broadband providers themselves, I'm sure, have been diving into it as well. So this is really an exciting, interesting opportunity. I did want to put up some maps that I'd seen recently comparing broadband speeds. The first is one that was in the New York Times in the online edition on September 13th and in the print edition on September 14th. And what they were talking about there was the speeds of broadband in Idaho. And maps like this are really what initially got me interested in better understanding speed measurements and the state of broadband. Because as you can see here, they're labeling Idaho as having 318 kilobits per second, and the fastest state in the nation as having 894 kilobits per second. This is really slow. This is less than a megabit per second. So the question is, why do they have the results that they have here? If you can compare this to what I had initially started looking at before the SamKnows provided data for the United States was speedtest.net data, and they measure Idaho as having 9 megabits per second, and Rhode Island is having 15 megabits per second. So the question is, why do these results differ by an order of magnitude? I think we now understand a lot about why they do. Just to put up some of the data that I've crunched from the FCC trial, what they show there is that Idaho, in fact, based on the way I calculated to try to make it as comparable as I could to the New York Times chart based on Pando network data, I calculated it using the 0 to 30 seconds. This is down in the details, and I averaged over the entire 24-hour period. So this is different than what the FCC mainly focused on, which was peak periods, but calculating it this way makes it most comparable to the Pando network data or the speed test data. So that's why I did that. There is small sample sizes for some of the states. Idaho, I think, had 55 test units there in Quest and Time Warner. But what you see there is that the users in Idaho, in fact, are getting about 90% of the speeds that they're subscribed to. And in Rhode Island, in fact, they're getting more. So there's probably more cable and FiOS in Rhode Island, is my guess. And it's not the case that, well, I just presented was a percentage, it's not the case that there's just very slow broadband in Idaho. There is Time Warner, which is cable, which is going to have 15 megabit or 10 or 7 megabit per second services, which you can see with the color. This comes from the National Broadband Map. So the conclusion of my comments today, I'll simply say that as a result of the FCC and SamKnows study, what you should expect is that the government will have better policy, that you will have better news analysis, and ultimately, too, I think it will drive better broadband because the broadband providers are looking at this data as well. Just some comments that we might discuss in the next bit here is some of the upcoming measurement challenges that really interest me. The first, I think, is better understanding broadband reliability. Well, I think what we've discovered is that speeds are not the major concern that a lot of people had. Perhaps there's some interesting things to look at with broadband reliability. Wireless broadband, I think, is very interesting. I was pleased. I actually did not know that SamKnows was moving in this direction already. And then finally, one of the biggest drivers of policy discussions, I think, going forward is, in fact, going to be video over the internet. So better understanding what impacts video performance, I think, is going to be an issue. SamKnows does have one of their tests which does measure this somewhat, but it's an area that's going to be important. I do have another 20 slides of data that we can put up if it's relevant at all for any of the questions that come up. But for now, I'm going to leave it here.
Totally relevant. Yeah. Okay, thanks. Now, before I got into the policy realm, I used to do network engineering, and my experience, which I think is typical of a lot of network engineers, is that you spend about 10% of your time on a new system getting the first packet to flow across the link, and then you spend the other 90% making it go faster. And it turns out there are many factors that determine how fast it goes. And these factors really come to the fore when you try to do internet performance measurement, because you sort of have to ask yourself, what are you actually measuring? And so when I was checking on the FCC's technical paper that they prepared in conjunction with the National Broadband Plan, where they went into the broadband measurement paper, there's only really one paragraph in there in that whole report that sort of describes the methodology that they used to come up with that initial finding that consumers are only getting half the speed they paid for. And that was they'd taken some data from ComScore, determine what the sort of mean advertised speed was, and then they'd measured the actual performance that ComScore found in a system that a couple of you were alluded to the fact that it's software based, but it was essentially the system is some software running on users' PCs that's measuring the performance of the things that users are doing on the internet. So it's like, what's the performance when I'm loading this web page that's on some random server somewhere on the internet? So the interesting thing about that analysis is that you're not just measuring the ISP's contribution to the speed. You're measuring the software on the user's PC. You're measuring the CPU of the user's PC. You're measuring the user's home network. You're measuring the ISP's on-net performance. You're measuring any transit agreements that the ISP or transit or peering agreements the ISP has to cross the boundary between their network and the network where the server is located. And you're measuring the server's performance. And you're measuring how many other people are on the server load, how many other people are using the server at the same time. So what they're actually doing is measuring the performance of the internet. And that's a wonderful thing to do. It's really good to know what the performance of the internet is as a whole, especially if you're an application developer and you want to roll out applications. But if we're going to take that number and say, well, it should be X, based on one component of that overall system, which is the ISP's claims, then the ISP can't do that much to actually make it go from 50% to 100%, right? I mean, in the overall scheme of things, what percentage of internet performance is under the control of the ISP? Or is it even possible to say? I mean, so what's the general range? So anybody wants to answer that?
Let me give it a shot, because in fact, the study that you're referring to, I've analyzed myself quite a bit, and you do point out, Richard, correctly, that they were measuring way too many things, but it turns out that really wasn't the killer flaw necessarily in their analysis. In their analysis, of course, they also had to go figure out what was the service speed that this subscriber is supposed to be getting, and they guessed at that. And the way they took, because the speed they measured, as flawed as you described, is a number, and now that's got to be divided by something. What's the service tier this customer is on in order to get that ratio of 50%? Okay, and the real failing in their methodology was that they would know the service tiers available in an area, and when they got an average for someone, they just would put that subscriber into the lowest service tier that they could put him into relative to their measurement, because they had a fundamental assumption that no one would ever get more than 100%. If anybody got over 100%, he'd be bumped into a better tier. Oh, and they never did that. So their alignment of the tiers is what was the real flaw. Okay, and in fact, even the SamKnows methodology, even as well as it was done, and I agree with Steve, this is a good data set and good report. A difficult aspect of it has been identifying the service tier. Right, so so you've got some subscriber in Idaho who's on the SamKnows network, which one of the service tiers that Time Warner sells in Idaho is this one really on? And what is that bandwidth that we should be putting into the denominator now? That's constantly a moving thing because the subscriber upgrades, downgrades, gets a new service, appears, disappears. It's a moving target. They've done a very good job to get that stable as possible. But so I'm not answering your question. What percentage of the ISP, the ISP, is the user experience? That is a very difficult question. Maybe Steve has an idea on it.
I don't think the answer to that is known. I mean, historically, there was a perception, and the reason that there's been a focus on the broadband providers is that historically people have always perceived that the bottleneck has been the broadband providers. So it wasn't an unreasonable place to start. However, from my own experience, it's very clear that there are bottlenecks in other places in the network as well. There's faults in other places in the network as well. Beginning to separate out and understanding those differences is an area of ongoing challenge. Did you have a comment?
Well, I don't know if you're opening it up for questions. So you put up the slide of the Pando map, and it struck me when I looked at that my understanding of Pando is that it's a peer-to-peer application, and so they were measuring the performance of their peer-to-peer application, in which case the upstream was probably the limiting factor, and so I wanted to get your reaction.
It's in fact exactly what I was mentioning to Alex before this panel got started. Particularly given my understanding of Pando and the size of their network and the number of peers that may be participating in getting content to a user that's grabbing it at any point in time, I suspect but do not know that the numbers they have are in fact much more determined by the upload speed. That's exactly right. So it is interesting. Upload speeds are lower than download speeds. Any data set you give me, if I understand the methodology well, there's probably something interesting to learn. Particularly in cases like this, though, it may not be that it's a lesson to learn about those given broadband providers.
Right, and that article completely misrepresented the results.
That's right. I think that's part of what we're doing here today is educating folks on the lessons that you can learn from this data, why this data set is an important data set, and how to think about this data set in relationship to some of those others that are out there.
I've got another question I wanted to put to Steve. Peter, you talked about terms, and I think what you're talking about is the influence that things like Slow Start, TCP Slow Start have. I mean, and you mentioned something about TCP Slow Start, and the fact that in order to retrieve some information from a website, it's not, you don't just send a single request. I mean, if you look at, analyze what's going across the wire with Wireshark or something, you don't just send a single request and get a single response. You actually send a series of packets, and you get a series of packets in return, and the rate at which you're sending those packets is determined by how fast you get acknowledgement in the beginning, because TCP has a slow start algorithm to prevent it from overloading the network. And when you open a new TCP connection, it's in slow start, and then it has to ramp up with successful acknowledgements to open the window. So the distance between client and server, the physical number of miles or kilometers that the bits have to travel, has a really significant impact on this, especially in applications like the browsers nowadays open tons of connections in the hope, and often the vain hope, of getting more performance. So if we are looking at how to make the internet run faster, is it time to re-engineer Slow Start, and are there in fact implementations of TCP that have altered the behavior of classical Slow Start?
Absolutely. So both, there's evolution in terms of both the TCP stack inside particularly the modern OSs, and there's evolution of the applications themselves. So the modern browsers, work hard at reducing the number of turns because, as Peter said, that is a big impact on user performance. So if you're typing into the Google address bar, it's resolving its guess of what you might end up typing even as you're typing. So before you hit enter, it's already done some DNS resolutions of what it thinks you may be trying to resolve at that point in time. So the browsers are working at cutting out those sources of latency, which will make speed more important. It's also the case that there's evolution in the TCP stack itself. So Google has a proposal, and the latest version of the Linux kernel has increased the initial congestion window. So the amount that is initially sent, as it went from 2 or 3 up to 10. So there's absolutely evolution there that SamKnows has an open platform that's capable of evolving to match these. So the other thing with Slow Start you mentioned, the SamKnows test does take this into account. There's what's called a warm-up period at the beginning before it starts measuring speed, and then it takes measurements from 0 to 30 seconds. I can let Alex maybe say if he has anything additional to say there,
exactly
but they do take into account those TCP issues.
Okay. And one last question before I open it to the floor. Do you expect within our lifetimes we're going to see 2 independent tests come up with the same answer?
Within the 95% confidence level.
Just say yes, Steve.
There is a question here of are we to the point where we want to standardize on any of these tests so that people can take this standard and go off and implement it in different ways. I personally don't know that we're there quite yet. I would like a little bit more time to be able to evolve the tests and learn the lessons. And just as you mentioned, actually, with TCP continuing to evolve, even if you did have a standard, you would need to be able to accommodate the changes that the users have there as well. Even if you did have 2 tests that were separate implementations of the same standard, the internet has variation all the time. It's constantly changing. Even if I take the same exact measurements from my home to MIT, which is very close, and the path doesn't change all that often, I get different results. So there is variation that's inherent to the internet.
Mm-hmm.
I agree with Steve that I don't know if we're ready to standardize, and if we did, you would get different results all the time, and we'll continue to get different results. I think an important aspect of should there be one test or more than one test, I think we should always have the door open for multiple views into performance. Instrumentation from in different places. There is no one perfect place to measure, nor one perfect way to measure. It'll constantly change, and the fact that maybe there are differences in results actually is productive, because it opens up inquiry into why there are differences in results, and you would like to always have some checks and balances on how people interpret it, and make policy based on multiple views as opposed to just one view.
I'm not sure what to add. I think that standards are coming though. I mean, people are working. I mean, we're talking to groups that are working on standardizing these tests. I think they are coming. But as Steve said, you're going to have to remain flexible so that you can amend your tests as the environment changes. But I think it's something that's going to happen. I'm not sure how that will impact creating identical data sets though.
Oh, one final question I want, because Alex, you've measured broadband performance in all these different countries. How's the U.S. doing compared to the rest of the world in terms of the sort of honesty of our ISP claims?
I can't talk to their honesty, but they seem like nice guys. Then.
You know what I mean.
But in terms of going back to the first question about validation, that was one of the challenges with this project, because the US is very different from the UK, for example. So the UK have one service tier, 20 megabits per second, unless you're Virgin Media, which is cable, which has 2 or 3 different service tiers. Now it's much easier then for us to allocate service tiers to customers, because they've effectively done it for us as a consequence of their marketing. Here in the States, it's much more complex because the ISPs have such a huge range of different service tiers. That in itself presents challenges for the consumer, because the consumer doesn't know which one to choose. There's so much choice there. But from our point of view, that was one of the key challenges in terms of, as you say, identifying which service tier they should be on. And the thing that we found is that the consumers didn't know. Our checks had to be incredibly thorough. Even then we had to manually go through the data for every single unit. And even when we were validating the service tiers with the ISPs, we couldn't always rely upon that information either. So that side of it was very, very complex. I think going back to your other point about what's within and without of the ISP's control, we did address this with the study. The ISPs donated test servers, and the whole point of that was for them to test the performance of their networks and then compare that with the performance of their networks with the MLabs nodes. And interestingly, we saw very little difference between those two data sets. The ISPs were performing as well off their network, than they were on their network. I think what's key for the next phase is that we look back into the home, which is completely beyond the ISP's control. And I think that's where a lot of the issues occur. So someone accessing their home internet connection over Wi-Fi on an old computer, or at the same time as 2 or 3 people in their home. FCC talks a lot about need for speed. I think it's possible to profile homes based on the number of devices they're using. So moving away from these kind of flash-based wizards that kind of throw up a few choices for you as a household, but moving towards what would be a much more accurate profile of how much connectivity you need, picking up on the points that Peter's made, and also how best you can manage that within your home.
Yeah, I think this is the kind of information that for consumers would be really valuable, is if the internet experience that you have in your home is frustratingly slow, how do you know whether the best remedy for that is to bump yourself into a higher speed tier with your ISP, or just to get a new PC, or maybe it's your router?
Yeah, it's a big deal. How do you know that your first port of call should be your ISP?
Mm-hmm.
And we've seen that a lot with people who have volunteered for the program. They've gone from a situation of having no data or ad hoc tests that they're running, mm-hmm. to having a very comprehensive data set. And we've seen people troubleshooting problems in their own home network, mm-hmm. using this data. I think, I say it again, reporting this. I think we've done quite a good job in making the data set available. I think that's a good thing. I think that the report was, as I think Steve said, it's a good kind of summary of, a lot of data. But I think that hopefully the research community will pick up on that and do more with it. But also I think we can do better stuff for the consumer as well. But it'd be cool if you've got a guy there who can just, identify that the reason why his, laptop isn't working is it isn't got anything to do with his internet provider. It's because of his router that he's purchased, for example.
Well, what I'm surprised at is that we have not had consumer groups get more involved in this. I think they could be mining this, and they could be advising. The consumer, we know in this room, most of us, these issues, certainly we do because we study it all the time, but they don't, the average consumer has no idea. The education of the consumer, at the user, at their experience, is made up of all these pieces and how to figure out which piece to upgrade the day you need to upgrade. I don't see much that's written in a public way about that.
I think that will happen though. That's come up in a couple of the meetings that we've had this week. In the FCC, we had another open session to talk about the next phase. I think that you will see the consumer groups. One of the points that was made in that meeting was that before they see something concrete, they've got finite resources, they're not sure where to place them. But now that they can see that there's a report there and there's momentum and there's a next phase. But I agree with you. I think But I think we could. I mean, SamKnows in particular could do more for those groups to make this data more accessible. I think.
Yeah, I mean, I think there is sort of a history of our consumer groups that work in this space have their roots kind of in the old days of the monopoly. They were like telephone critics. And now they spend an awful lot of their time focused on the behavior of the 15 monopoly ISPs. And maybe not enough on providing consumers with the information that helps them understand, what goes on in this brave new world of the internet.
I think that's a hard call. How do you? I mean, Steve's done some great research on this. How you and suggestions on how you make this data relevant to consumers.
Okay.
Let me just say, it's not that there is no one working in this space. We have in the room today the New America Foundation, which is a participant in the measurement lab. And while simplistic looks at some of that data lead you to wrong conclusions, those tools have actually been really instrumental in helping me understand my own connection. And I suspect the same is true for other consumers as well. So there is an effort to help consumers. We can certainly do better, but there are efforts underway.
Okay. So, I guess questions. I think your hand's been up to long. If you could just identify yourself and your affiliation.
Okay, my name is Itsumi Kano from Kyushu University from Japan, and thank you for the presentation. And I personally conducted similar kind of measurement in much smaller scale. I collected 1,000 samples from the Japanese broadband users and asked them to measure the speed using the Ookla speedtest.net site. And my result is that about 25% is the average of the actual download speed compared to the advertised speed in Japan. So my question is, I have one question to the Alex and one question to the Mr. Sevcik. And in the Alex presentation, you say that FCC software-based measurement is about 43 to 57% of the advertised, and SamKnows in the measurement is about 80%. Could you elaborate a little bit more about why those differences come from? And my next question is from Mr. Sevcik, is that you point out some graphs which show in the vertical axis is the percentage between the actual speed and advertised speed, and horizontal axis is some kind of speed tiers, and you show some kind of positive graphs. The higher speed attain the higher percentage, but my results show that the slope is actually negatively sloped. So could you explain, do you have any ideas why this happens? What makes the difference between Japan and US?
Okay, so I mean, I really, I mean, the Ookla speed test is fantastic, and I think the first point I'd say is that what we're trying to do is just do studies in a very particular methodology, but that doesn't mean that we're the only. And Steve's mentioned the MLabs guys have got a whole load of tests. And I think these kind of tests are complementary to each other. They are fundamentally different in terms of the methodology, though. We did contemplate using software based on PCs, for example, but we were concerned about, not being able to capture traffic within the home, with multiple people running tests or using the internet at the same time, how that affect our results. We're concerned about, home Wi-Fi connectivity, how that might impact the results. We're concerned about not being able to validate the service tiers for the panelists. You've got to bear in mind that you can't rely upon what the customer's telling you. I mean, we found that. Just to give you an example, in our first study in the UK, 12% of the panelists didn't know who their ISP was, but that didn't stop them railing against the ISP that they thought they were with. So you enter this and you just cannot. You have to really look at finding your own information around speed tiers. I think the other thing is, and I don't know enough about the Japanese market, is that the US ISPs appear to sell service tiers that are much more closely aligned with what their customers can actually achieve with regards to technology, and that's certainly the case with DSL. And then you look at cable and Fios, and you see the difference in those technologies. How they can be engineered differently, and then you take into consideration power boost as well, which we didn't see in the UK. I'm not sure if you have power boost in Japan as well, but that had a very significant impact on the data that we're seeing, and I think we released in the report the differences between power boost and non-power boost as well. So I think the thing that I would say is that I think it's a very useful data set, but the methodology is fundamentally different. I think that, as we've said a couple of times, it's measuring quite a lot of stuff that's beyond the control of the ISP.
Well, I think to answer your question about the fact that I presented a curve that showed that as you bought more bandwidth, the chances of getting it climbed. And you're saying that you've done a similar analysis with Ookla data and you've got a curve that goes in the opposite direction. I don't know the details of your analysis or your measurements, but I would suspect that one of the things that Ookla is measuring here is the performance of the PC's ability to pull the data off the server and the server's ability to move it into the PC, and it's also measuring performance of the home area network. Okay, if there's any limiting factor in those other things other than the ISP, then in fact you're seeing a limit of performance. So my question to you would be, did you ever see really, really good performance? Because I also understand that in Japan some ISPs do provide very high performance. That means that if the numerator is not changing much because you're actually measuring the performance of the PC in the home network, but you divide it over a denominator of performance that the ISP is selling, 10, 100 megabits per second. Well, at 100 megabits per second, the Ookla system just can't keep up. Your PC can't do 100 megabits per second, and therefore it looks bad because it's the same 50 megabits per second. 50 megabits per second divided by 10 looks great, divided by 100 looks terrible.
And the server.
And the server.
The other test
The server at the other end. So a crucial thing is that if the results are themselves limited, then as you divide it by some perception of what the speed should be, like 100 megabit per second service in Japan, then it'll look bad. But that's because you need another method that will actually run at 100 megabits per second.
Two quick questions. Not knowing a whole lot about the technical details of the test, one question I had is whether the test is constructed in such a way that, say, an ISP can't sniff packets and give priority to packets going to the test servers. Just a dumb question, but let me just throw it out there. That would seem like if you wanted to boost your performance, everybody does active traffic management. Why not, send packets to the servers faster? Just a question. And then the second question is, I found the chart you constructed with the speed tiers versus the effective utilization, the capacity that was actually delivered. Is fascinating. How much confidence do you have? You were expressing doubts about the classification of the speed tiers of the data, and I guess my question is, how confident are you that the x-axis doesn't have a lot of measurement error? Because you seem to be suggesting the opposite.
Well, I have confidence that in this data the speed tiers were properly assigned because I know the efforts that people went through, and we've done checks to see whether there are any outliers, and there used to be outliers and not outliers anymore. So it really that's not the issue. I think that's I'm very confident in that chart. Your question as to whether or not the ISPs figured out who these guys are, well, they didn't even know who these guys were. They were blind tests, blind assignments, and it was very difficult for the ISPs to try to do that. And from a technology point of view, the way the ISPs networks work, for them to be able to cherry pick and figure out that we're going to, improve the performance. Fact of the matter is the internet only runs at a certain speed, no matter what kind of technology you put in place. Okay, and you can't make, a packet goes through a router at a certain speed. You can have it go through that router slower, but not faster. Okay, only slower because it's congested, or you can arbitrarily make it slower. You can put a timeline in there, a time loop, and say every one of your packets is going to go slower. But to make every one of your packets go faster than the whole community we're supporting here, that's just not inside the DNA of the way all these systems work.
But your graph seems to show that not all packets are created equal, obviously.
Well, there's a different interpretation. Let me tell you, it certainly wasn't because they were trying to choke down the lower performance guys.
So why was it then?
Well, I'm open to answers from others. My interpretation is that the left-hand side of the chart, which was around 1 to 5 megabits per second, is old technology, old infrastructure that has been around for a long time, that has a lot of subscribers on it, that may be higher utilization. As you go to the high end, brand new fancy stuff that has only, it's newer, better, it's the newer stuff, okay? And B, it has fewer subscribers on it. So it's also, why is my stay at the Holiday Inn not as nice as the one at the St. Regis? Not that I've stayed either one of them, but.
I'd just like to add to that. I mean, that came up a lot at the start of the project. When we wanted the ISPs to be involved, people were instantly saying you can't get them involved. They're going to do everything they can to game the results. We spent a long time on this. So that was the reason why we set up the code of conduct. That was actually suggested by the ISPs as a way to govern their conduct during the course of the project. We also would monitor the data very closely, and we went so far as creating and as Peter said, these people were blind trialists. We weren't giving the ISPs their information. What we also did was that we collected a control data set for every single panelist, and we would compare their results over time with that control data set to check for anomalies.
Can you explain what you mean by control data set? So
Yeah,
for
we
the same
just
household, you were doing before and after the.
That's right. So we had an extended onboarding process with each one of these volunteers. I've got a timeline there. But before we started making the data available to anyone, or even validating the service tiers, or letting anyone know that these people have signed up, we'd collect a data set from them for a period of time, and then we'd use that data set as a control data set.
Okay, could people please limit themselves to one question and make it a question and not a speech? Gentleman over here.
The panelists did a good job of laying out
Identify yourself.
Larry Sargent, CenturyLink. The panelists did a good job of laying out the multiple variables that affect a user's internet experience. From the standpoint of where you see us heading in terms of testing and measuring and studying, do you see us reaching a point where we are going to get all the relevant variables in one place being tested so a consumer can look at it and say, okay, I want this iteration of browser, I need this much CPU capacity, I need, maybe you classify apps in certain classes, and if you have an app in this class, you get this, so that the user has a total view of all the relevant things that affect their internet experience. And this gentleman here, Steve, articulated why we focused where we started this focus because of a certain assumption, but we now know that assumption is not valid, that it's not just the speed at which you get your internet connection. So are we going to get to a point where we get a total experience view?
I don't know, I called for it. I asked for the fact that we need to be measuring or documenting all those other aspects that go into the total experience. And there's been, interestingly, I think there's been a reluctance I think that the infrastructure is getting measured pretty well, and it's going to continue to get measured, particularly if SamKnows starts measuring in the home, and you can actually get that piece of the puzzle. So over time, we're going to get a lot of pieces of the puzzle of the infrastructure or the delivery mechanisms of the internet, but that's not the user experience. The user experience is which app are they running, and which options on those apps have they turned on. And no one seems to want to go there. I mean, you have any idea of how to quantify that?
To a degree, I think you're getting this a little bit already, and you're going to see more of it from the content and service providers themselves. So YouTube is one example of this. If you go to youtube.com/my_speed, they'll show you what they believe they've, a quantification of your experience with YouTube. Now, unfortunately, from my perspective, they label those graphs with the broadband provider's name, and it's not always clear that it's the broadband provider's fault. But that is an end-to-end measurement of the YouTube experience. Netflix also put out a chart aggregated over ISPs, not individualized. That has come out. BitTorrent has released some charts to one newspaper and said they had a lot more of this that they could do. It's very clear that the gaming companies have all kinds of metrics that they collect internally about game disconnects and things like that they could be releasing. So there's a lot of data out there. Some of it is leaking or put out there already. I think you're going to see more of that.
But Steve, I think it's still not really the right thing that YouTube or Netflix should be saying. So I can do YouTube regular or HD.
Yep.
When I click on HD, there isn't a pop-up that says, "Oh, by the way, do you have at least 10 megabits per second coming to your home? Otherwise, don't bother." Because they would never want to say that. You know, just go ahead and suffer at HD not working well, and then blame the ISP.
Nowhere did I endorse any of the results as being, the right set. It's a start, and there's a lot that does frustrate me, particularly as an academic and a researcher, because the methodologies aren't documented. It's really hard to understand. We're at the same point with those that we were a couple of years ago with all the speed measurements. It was hard to understand and compare. It was hard to understand what the methodology was, but those are organizations that have an interest in measuring that, and they are already. So I think more of that is going to become public. Now, there's other ways that we can do this as well. I think, perhaps SamKnows is going to be doing some things in this space that gives us a better idea of the home network. That's very useful.
Well, I was going to add to that actually. This is something that we're looking at for the second phase of the FCC. But the one thing that I'd say before mentioning on that, if an ISP representative were on this panel, they'd immediately say we've got to get the balance right between good data and overloading the network. And that's something that we've discussed at length, and that's a big part of scalability. If you set out to try and measure everything, you're going to end up destroying the thing that you set out to measure, basically. But that's a bit dramatic. I'll tone that down. But what we're looking at with these kind of applications is if you imagine what we're trying to do is set up points in the network, including the home. So you might have the laptop, then you've got what we call the white box, our measurement device. Then we have the test servers. They're out in the network. They're either on the ISP's network or off with the MLabs guys. What we're talking about with that's going to address Peter's point is actually going to the content providers as well, and actually running tests between those 2 points as well. But just to bring this full loop, I think we have to focus on a certain number of applications and not try and measure everything. But I think that's how you start off with this kind of stuff. You start off kind of profiling, measuring, and then you work towards standards.
You absolutely do have to be skeptical of any of those that are labeled when they're end to end. If you see them labeled with the broadband provider's name as the one that's at fault for the lower or performance, you should be very skeptical.
Yeah.
It's an end-to-end measurement in those cases, and the faults can be anywheres.
But that would be cool if we could look at YouTube, how it performs to the termination point in the home, and then how it performs around the home. I think, and that's absolutely something that can be measured.
No, I think it'd be interesting if we could measure when the side effects that YouTube and Netflix create for other applications that are running on the same same network that by people who aren't doing those just because
that's why you're in a device that sits by the gateway, because you get a view of the whole network. Mm-hmm. Again, aside from kind of network congestion, another point that I would make is about privacy and protecting consumers' right to privacy, because we could totally geek out on this and just set out to collect a fantastically rich data set, but we'd never want to do anything to compromise our volunteers or consumers' privacy as a whole.
Yeah, at one stage in my career when I was doing some performance measurement on Wi-Fi systems, and I decided to do it at home because I had sort of less radio interference at home at the office. And after about 2 days of basically running nonstop Wi-Fi performance measurement tests in my home, I found out that my next door neighbor upgraded his Wi-Fi router to 11N, and presumably he was not getting any. He was a guy who works at home, and he was probably having a pretty frustrating experience when I was over there consuming 98% of the theoretical capacity of Wi-Fi for 2 days solid.
I gather that if you drive a car around to take photos for a mapping project, you can sometimes collect data back.
I've heard stories to that effect. I don't know if that's true. It may be one of those internet myths, you know. Yeah. So anybody else?
Just a quick question. Peter brought up the issue of what he called the hidden traffic, or, you know, this clearly is a broad range, of, including all the way from mandatory network maintenance to completely voluntary marketing, whatever traffic that's occurring. Have there been any studies or analyses of this? And obviously, everybody contributes to this. The ISP does, the website operator does, the application, everybody's got a hand in it. But have there been any studies done of this aspect of the traffic?
Well, I think we should distinguish. We actually separately, NetForecast measures the consumption of traffic on ISP networks for the purposes of validating the accuracy of the consumption meters that are out there. And I can tell you that, in fact, the ISPs produce a tremendously low level of traffic. That is really in the noise, and does not. It's very it's very modest. Okay, the traffic that I showed on that chart is the traffic that's being produced by the websites and their services and their advertisers and all the other places you connect to. So, for instance, that convenience of prefetching and figuring out that I'm looking for a hotel in Boston. Okay, that's traffic. Now, yeah, it's for the consumer. It's a nice thing. It makes things speedy. But in fact, when I mistype and start all over again, and that was traffic we really didn't need to do. And it's alarming that our measurements show that it is now, this traffic is growing at 10% a year. The organic growth of web traffic is 20% a year. So this background traffic, or this hidden traffic, is now a third of traffic growth.
But how much of all what purport would you intuitively say is
total proportion?
Not total. It's of the web experience, not of video. I'm not throwing in video. This is just relative to only web. No one is, that I know of, is seriously measuring that. We measure it, but we're only one company.
I know one of the trends on some of the sports-related websites is they seem to assume that they have the full right to blast videos on your, you go to, I sometimes write on a blog that the San Francisco Chronicle has for my baseball team that I follow, and Major League Baseball has a video ad that you just go to that page and they start playing video, and I'm thinking, well, that doesn't affect my iPad because it's Flash. But if I'm accessing that from a wireless system where I've got a metered rate plan,
you're using more capacity for that stuff than what you want.
I mean, it would be cheaper for me just to pay them to not show the damn ad. But well, that's not the business model of the internet. So I guess it's time to wrap up. Which is the best performing ISP in America? It's Verizon, right? Verizon Fios. I mean, the investment in that fiber optic network has paid off.
It depends. I mean, it was great for us to see the data from that, because you can just see how it can be engineered in terms of the reliability of the data. But I don't want to take anything away from those guys. It's a fantastic product, but when you look at what's the best performing ISP, you're talking about speed there, and I think there's other things that we're going to be looking at in terms of coverage. So I think there's other stuff for us to look at in terms of, rural broadband's a big thing that's coming up. There's not a lot of Fios available in rural America currently. So I think, yeah, absolutely, the data from the Fios connections is very impressive. But I think in terms of how they're performing, we're going to look at availability as well.
Well, and speaking of availability, it brings us to Comcast. They're not exactly letting their customers down either, are they?
Yeah, I mean, you're going to get me to run through each ISP one by one. Get some high fives going.
I think the thing is that my frustration with this is that you guys do this incredibly difficult, challenging work to actually get a real empirical handle on what's going on the internet in terms of performance, reliability, these other factors. But before that information gets to the consumer, it's filtered through journalists and bloggers and I mean the big tech blogs, you know, when they get one of these 50% findings, they go nuts and big headlines over that. But, you know, you get a finding that says, well, actually, people are pretty much getting what they paid for. Sometimes a little bit more, sometimes a little bit less. But, you know, generally we're pretty much the ISPs are doing what we would expect them to do. That's just not a story.
Yeah, and I think my answer to that is that I don't think we can rely upon the media to disseminate that kind of story. And that's not really the purpose of the project, to create media stories either. I mean, we're trying to create data sets for consumers, and I think that if we can, I mean, I completely take responsibility for that in terms of we need to improve our reporting, we need to make it more relevant to consumers, we need to work with guys like the New America Foundation, you know, the guys here as well who've done a lot of work on this. And I think if we can disintermediate the media and just take this technology and these tools directly to the consumer, then it will become less relevant anyway. But that said, I mean, we've had a lot of good comments from you know, tech press about the study. You know, the FCC picked up a lot of good comments, particularly on the actual day. There's a lot of activity around that. But you know, it's as much about what people want to read as what the media organizations write, and that's not just broadband speed. That's everything.
Yeah, man bites dog. Well, thanks for coming.